Rhode Island does not explicitly require knurled hardware on door hardware on the outside of electric rooms. However, in Massachusetts, the Massachusetts State Building Code 780 CMR requires knurled hardware on door hardware on the outside of electrical rooms. This requirement is found in Section 530.4 of the Code, which states doors opening into an electrical room shall be provided with panic hardware equipped with knurled knobs, handles, or bars. This requirement helps ensure that people can quickly and easily exit an electrical room during a power outage or other emergency. The knurling provides tactile feedback, allowing people to identify the door even in the dark. Architects and contractors should be aware of this difference when designing and constructing buildings in these states. The Massachusetts Code specifies the use of panic hardware equipped with knurled elements on doors opening into electrical rooms. The purpose of this knurling is to provide a tactile indication, especially useful during emergencies such as power outages, allowing individuals to quickly identify the exit without relying on visual cues. Rhode Island's building codes, based on current research, do not have a corresponding explicit requirement for knurled hardware on electrical room doors. The presence or absence of such a requirement can influence the choice of door hardware during construction. Building codes are sets of regulations governing the design, construction, alteration, and maintenance of buildings. These codes are adopted and enforced by governmental jurisdictions to ensure public safety, health, and welfare. Building codes address various aspects of construction, including structural integrity, fire safety, accessibility, energy efficiency, and electrical and mechanical systems. They are typically based on model codes developed by organizations such as the International Code Council (IC) or the National Fire Protection Association (NFPA), which are then adapted and amended by state and local governments to meet specific needs and conditions. Code compliance is the process of adhering to all applicable building codes and regulations during the design, construction, and operation of a building. It involves understanding the specific requirements of the codes, incorporating them into the building plans and specifications, and ensuring that the construction work is performed in accordance with those requirements. Code compliance is essential for obtaining building permits, avoiding costly rework, and ensuring the safety and functionality of the building. Electrical rooms are dedicated spaces within a building that house electrical equipment such as switchgear, transformers, panel boards, and control systems. These rooms are designed to provide a safe and secure environment for the electrical equipment, protecting it from environmental factors and unauthorized access. Electrical rooms are typically located in a central area of the building, close to the main electrical service entrance. They are designed to meet specific requirements for fire assistance, ventilation, and access, as outlined in the building codes. Panic hardware is a type of door latching mechanism that allows occupants to quickly and easily exit a building during an emergency. It typically consists of a horizontal bar or touchpad that, when pressed, releases the door latch and allows the door to swing open. Panic hardware is required on doors that serve as exits from assembly occupancies, educational facilities, healthcare facilities, and other high occupancy buildings. The purpose of panic hardware is to provide a means of egress that is easy to operate even in crowded or stressful situations. Knurling is a manufacturing process used to create a textured surface on a metal object. The texture is typically a pattern of diamond-shaped or straight ridges that provide a better grip or tactile feedback. Knurling is often used on knobs, handles, and other components that need to be easily grasped or manipulated. In the context of door hardware, knurling is used to provide a tactile indication of the door hardware's function, especially in low light conditions or during emergencies. Tactile feedback refers to the sense of touch and the information it provides about an object's surface texture, shape, and hardness. Tactile feedback is important for tasks that require fine motor skills or that need to be performed in low light conditions. In the context of door hardware, tactile feedback is provided by the knurling on the knobs, handles, or bars. This tactile feedback allows people to identify the door hardware even in the dark, making it easier to exit the building during a power outage or other emergency. Emergency egress refers to the ability of occupants to safely and quickly exit the building during an emergency, such as a fire, earthquake, or power outage. Emergency egress is a critical aspect of building safety, and building codes include specific requirements for the design and construction of exit routes, including the number, size, and location of exits, as well as the type of hardware and signage used. The goal of these requirements is to ensure that all occupants can safely evacuate the building in a timely manner. The Massachusetts State Building Code, also known as 780 CMR, is a comprehensive set of regulations governing the design, construction, alteration, and maintenance of buildings in Massachusetts. It is based on the International Building Code, IC, and other model codes, with amendments and additions specific to Massachusetts. The Massachusetts State Building Code covers a wide range of topics, including structural integrity, fire safety, accessibility, energy efficiency, and electrical and mechanical systems. It is enforced by local building officials and is designed to ensure the safety and welfare of building occupants. Section 530.4 of the Massachusetts State Building Code 780 CMR specifically addresses the requirements for doors and hardware in electrical rooms. This section includes provisions for the size, fire resistance, and accessibility of doors, as well as the type of hardware required. As mentioned earlier, it mandates that doors opening into electrical rooms be equipped with panic hardware with Knurled knobs, handles, or bars. The Rhode Island State Building Code is the set of regulations governing building construction and safety in Rhode Island. While it does not explicitly mandate Knurled hardware on electrical room doors, it is crucial to consult the most current version of the code and any local amendments to ensure compliance with all applicable regulations. Architects and contractors should always verify the specific requirements of the jurisdiction in which they are working. Model building codes, such as the International Building Code, IC, serve as a basis for many state and local building codes. These model codes are developed and updated regularly by organizations like the International Code Council, IC, to reflect the latest advancements in building technology and safety practices. State and local jurisdictions can adopt and modify these model codes to create their own building codes that address specific regional needs and conditions. When designing and constructing buildings, architects and contractors should consult the applicable building codes for the specific location to ensure compliance. This includes understanding the requirements for electrical rooms, door hardware, and emergency egress. In addition to building codes, other regulations and standards may apply to electrical rooms and door hardware. For example, the Americans with Disabilities Act, ADA, sets accessibility requirements for buildings, including the force required to open doors and the type of hardware that can be used. The National Electrical Code, NEC, contains requirements for the installation and maintenance of electrical equipment, including the wiring and grounding of electrical rooms. It is important to be aware of all applicable regulations and standards when designing and constructing buildings. The authority having jurisdiction, ORG, is the governmental agency or organization responsible for enforcing building codes and regulations in a specific area. The AHA may be a local building department, a state agency, or a federal agency. Architects and contractors should work closely with the AHA to ensure that their projects comply with all applicable requirements. The AHA can provide guidance on code interpretation, conduct inspections, and issue permits and certificates of occupancy. Consulting with the AHA early in the design process can help avoid costly rework and ensure a smooth permitting process. Continuing education is essential for architects, contractors, and other building professionals to stay up to date on the latest building codes, regulations, and technologies. Many organizations offer continuing education courses and seminars on topics such as building codes, fire safety, accessibility, and sustainable design. Participating in these programs can help professionals maintain their licenses and certifications and improve their knowledge and skills. Staying informed about changes in building codes and regulations is crucial for ensuring compliance and providing safe and functional buildings. In summary, the requirement for Knurled hardware on electrical room doors varies by jurisdiction. Massachusetts mandates it in Section 530.4 of 780 CMR, while Rhode Island does not explicitly require it. Architects and contractors must consult the applicable building codes and regulations for the specific location to ensure compliance. Paying attention to details such as door hardware can significantly impact building safety and accessibility, particularly during emergencies. Understanding the reasoning behind code requirements, such as the tactile feedback provided by Knurled hardware, helps in creating safer and more functional buildings. Remember to always consult the most current version of the applicable building codes and to work closely with the authority having jurisdiction to ensure compliance. The design and construction of electrical rooms must adhere to stringent safety standards. These standards are in place to protect both the electrical equipment housed within and the individuals who may need to access the room for maintenance or in emergency situations. One critical aspect of electrical room design is ensuring adequate ventilation. Electrical equipment generates heat, and without proper ventilation, the room temperature can rise to unsafe levels, potentially causing equipment malfunction or failure. Building codes often specify minimum ventilation requirements for electrical rooms, typically expressed in terms of air changes per hour or cubic feet per minute of airflow. These requirements may vary depending on the size of the room and the amount of heat generated by the equipment inside. Another important consideration is fire safety. Electrical rooms should be constructed with fire-resistant materials to contain any potential fires and prevent them from spreading to other parts of the building. Fire-rated walls, doors, and ceilings are commonly used in electrical room construction. Additionally, fire suppression systems, such as sprinklers or fire extinguishers, may be required depending on the size and occupancy of the building. Access control is also a key aspect of electrical room safety. Unauthorized access to electrical equipment can pose serious safety risks, including electric shock and equipment damage. Electrical rooms should be secured with locks or other access control measures to prevent unauthorized entry. Warning signs should be posted to alert individuals to the potential hazards inside the room. Proper lighting is essential for safe and efficient work in electrical rooms. Adequate lighting levels should be provided to allow technicians to clearly see and work on the equipment. Emergency lighting should also be provided in case of a power outage. The layout of electrical rooms should be carefully planned to ensure adequate space for equipment installation, maintenance, and access. Equipment should be arranged in a logical and orderly manner, with clear pathways for technicians to move around. Sufficient clearance should be provided around equipment to allow for safe operation and maintenance. Grounding is a critical safety measure in electrical rooms. All electrical equipment should be properly grounded to prevent electric shock hazards. Grounding systems should be installed in accordance with the National Electrical Code, NEC, and other applicable standards. Regular inspections and maintenance are essential for ensuring the continued safety and reliability of electrical rooms. Inspections should be conducted to identify any potential hazards, such as damaged equipment, loose wiring, or inadequate ventilation. Maintenance should be performed on a regular basis to keep the equipment in good working order. Training is essential for individuals who work in or around electrical rooms. Technicians should be trained on the proper procedures for operating and maintaining electrical equipment, as well as the hazards associated with electricity. Emergency procedures should be in place to address potential incidents, such as fires or electric shocks. Electrical safety is a shared responsibility. Building owners, facility managers, and electrical contractors all have a role to play in ensuring the safety of electrical rooms. By working together and following established safety standards, we can prevent accidents and protect lives. The National Fire Protection Association, NFPA, offers a wide range of resources and training programs on electrical safety. These resources can help individuals and organizations stay up to date on the latest safety standards and best practices. The Occupational Safety and Health Administration, OSHA, also provides guidance on electrical safety in the workplace. OSHA regulations cover a wide range of electrical hazards, including electric shock, arc flash, and equipment lockout/tagout. Compliance with OSHA regulations is essential for protecting workers from electrical hazards. Arc flash is a dangerous phenomenon that can occur when electrical equipment malfunctions. An arc flash is a sudden release of electrical energy that can cause severe burns, blindness, and even death. Arc flash hazards should be assessed and mitigated in electrical rooms. Mitigation measures may include the use of arc-resistant equipment, personal protective equipment, PPE, and engineering controls. Lockout/tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. These procedures involve disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch to prevent it from being turned back on. Lockout/tagout procedures are essential for protecting workers from electric shock hazards. Electrical safety audits can be conducted to assess the safety of electrical systems and identify potential hazards. Audits should be performed by qualified professionals who have expertise in electrical safety. The results of the audit can be used to develop a plan to address any identified hazards. By taking a proactive approach to electrical safety, we can create a safer environment for everyone. The principles of electrical safety apply to all types of electrical systems, from residential wiring to industrial power distribution. Whether you are working on a small electrical project or a large construction project, it is essential to follow established safety standards and best practices. Remember that electricity is a powerful force that can be dangerous if not handled properly. Always take the necessary precautions to protect yourself and others from electrical hazards. If you are not qualified to work on electrical equipment, do not attempt to do so. Hire a qualified electrician to perform any electrical work that needs to be done. By following these guidelines, we can all help to make our homes, workplaces, and communities safer from electrical hazards. Always consult with a qualified electrician or electrical engineer for specific guidance on electrical safety matters. They can provide expert advice and assistance to ensure that your electrical systems are safe and compliant with all applicable regulations. The information provided here is for general informational purposes only and should not be considered as professional advice. Always consult with a qualified professional for specific guidance on any electrical safety matter. The world of electrical codes and regulations can seem complex and overwhelming, but it is essential to understand and comply with these requirements to ensure the safety of people and property. By taking the time to learn about electrical safety and following established safety standards, we can all contribute to a safer and more electrically secure environment. Stay informed, stay safe, and always prioritize electrical safety in all of your activities.